check up. Okay. So hello and thank you for joining this webinar today. My name is Christoph Staud. I'm account manager at Macq, and I'm glad to present you our QCAM5 today. And why this webinar today? Because after 2.5 years of intense work, we have finally succeeded to get our homologation in Belgium, so the Belgian homologation for average speed, based on this product. So this is certainly a highlight of this presentation, the homologation, the Belgian homologation for section control, average speed, point-to-point measurement, trajectory control. So there are many names for the same thing. From the content point of view, I would like to start with average speed, what it is, what are the key features, the key aspects from our solution, then to have a glimpse of, or an overview of our performance of the solution, then the functionalities, not only for this solution, but in general, coming from our camera, QCAM5, then on which hardware it is based, and finally also some insights in for our installation instructions. So as I said, average speed is one name, but on the international level, you can also see sometimes section control, point-to-point, but more or less what it is, because it's everything, also even if there are different names, it's always the same. So it's the measuring the average speed of a vehicle between 2 points, A and B. And so more or less you can have the distance D, which is clearly defined, which you divide afterwards by the time difference between, or what the vehicle has used to pass between point A and B. So D divided by the time difference, you have the average speed. So this is the operating principle of this solution. A typical deployment is you have 2 or more QCAM5 cameras, of course, because you need one at point A and one at point B at least. Then secondly, you need the corresponding infrastructure to install these cameras, so either pole or it can be also a gantry. Then a third point is the technical cabinet, because of course you need data, you need electricity. Normally you will merge all these kind of aspects, technical aspects in one technical cabinet. Then you have the network, which can be either wireless or cable, based on cable, so Ethernet or wireless, 4G for example. And then you have the back office based on the central server, which is called MQ software. MQ stands for Macq Mobility Manager. And this software is installed on the central server, which is used to evaluate all candidates, all passing vehicles. Then, of course, you need front-end equipment to connect to this back office software, and where you can screen and validate all the infraction candidates. From the setup point of view, you have either possibility to put it on a pole next to the road. There is possibility of our solution to recognize the vehicles from the front or from the rear. So both is possible. And the second, more or less common setup is the gantry, on the gantry, so on top of the road. And here what you can see in additionally on the picture are the green squares. This indicates that our camera makes several pictures very fast, one after the other. That means it depends, of course, the frames per second of the camera, which is around 30-35 frames per second. And that means when the car is passing by, the camera is taking a picture from the same vehicle several times. Now, as you understood, it's based on timestamps, and the distance. So that means it's quite important to measure both aspects very, very accurately. Here you can see a schema of the arrow I. Arrow I stands for region of interest. And this is the area where the vehicle plate, so the license plate of the vehicle, is captured and taken as ground truth. So what you can see is the field of view of the camera, which is here marked as a blue square. This is what you really see with your camera, and within this field of view, you can define by putting a certain polygon surface within your camera where should or may be the ROI, the region of interest. And then if you take the half of it, you have the reference point where the trajectory or the section starts. And on the other hand, at the exit portal, that means where at the point B, you have the same, the reference point where the trajectory ends. And that means the big D, so the distance, defined distance, is calculated between both lines. So we have already, or we had already, several homologations for average speed. So why we are now proud to announce that we have a new one? Because there are also new things inside. So first of all, is that we are able to monitor average speed also on very short trajectories. So that means from 200 meters upwards. Then secondly, we made our solution, or we designed our solution in such a way that it's for the company who installs is a very easy, as easy as possible, because we are able to install it up to 10 meters from the road. And so that gives a certain freedom for the installation. And also a brand new feature in our camera QCAM5 for this solution average speed is the field of view monitor. I will explain in the next slide what it is, but in briefly, the main target of it is that thanks to this feature, it's easy to maintain the solution during the years of its installation. So let's dive in within the field of view monitor, because it's quite new. What does it mean? So how it works, it's first on both, so on camera level and on the back office MCube software, there are several additional software parts on both to monitor it. Then the goal and main advantages of this feature is first that we monitor automatically any changes of the field of view. That means if the camera is moving due to wind too much, or there's of course some tolerances, but if it moves too much, or it's even moved due to vandalism, the pole is broken down by somebody, then this field of view monitor capture this change and send an alert to the back office. Secondly, thanks to this feature, it is also possible to simplify the cleaning, the maintenance of a camera. Why? Because until now, if you want to clean, you need, if it's, for example, on a pole very high, either you need an aerial platform which goes very up, and so it makes some additional costs, because you don't want to move the camera, because once it's installed, it's homologated for a certain distance, etc. So normally you cannot move it anymore. So you need to go up and not the other way around, because with the field of view monitor, it's possible if it's on a pole, and if you choose an articulated pole which you can put down, then you are able to clean it, to put it back on the right positioning up. And thanks to the full field of view monitor, it ensures that the homologation is still valid. On the other hand, on highways, on roadways, you don't need to close anymore if you have the corresponding adequate mounting structure, where you can also tilt and move the camera up, so you can go on the gantry, clean it, and put it back. That enables that you can go without closing highways, putting your truck to clean it. So this is a very great advantage, one of the main advantages of why we designed and developed this field of view monitor. How it works, Basically, it's a very simple approach. That means that the field of view monitor, it checks regularly if the field of view reference image, there is on the reference image, there is configured a mark on the ground, on the road. And this mark in the reference image is always compared to the current mark, with the same current mark on the ground when it is checked. And if it's not anymore aligned, so that means there's a deviation, so from a geographical point of view, the deviation, then the solution detects there's indeed a change of the field of view of the camera. So here's an example how it can look like in reality. So on top, the field of view marker. So it's not only in line, but of course with 3 dots, so that at least 3 corners. So it's better to position in a 3D world. Then you can see below the screenshot of our embedded software, which is inside the camera itself. That means here you can configure and assign the field of view marker. And here's an example of a picture of an articulated pole where you can install it on the top. And if you need to clean it for some reasons, you can tilt it down, go up again, and the field of view monitor ensures you, or ensures also towards the end client, that it's still valid. So that means it has not changed the positioning, field of view, the ROI is still the same, etc. Our new homologation, we have in fact 2 homologation because we have 2 speed classes. Let's explain first what it is. So speed class A is more or less a speed where on which the vehicles cannot go faster than 150 kilometers per hour. Class C is on roads where you can speed up to 250 kilometers per hour. That means class A is in Belgium at least more or less used for cities, within cities, for example, with a limit of 50 kilometers per hour. And class C is of course meant for highways. Secondly, on the class A, so for example in cities, we are, as already mentioned and announced, we are able, and as our solution is homologated, to have a section length of minimum 200 meters, which is of course great if you have few sections in cities in front of schools, in front of spots within the cities which are, from a traffic safety point of view, very, which needs to be taken into account by the city. Then you can also have this solution installed on trajectories which are 200, 250 meters long. Class C is from 500 meters, which is completely a reasonable length for highways and for such speedings. Then the ROI length, as you can see, there is quite difference because of course the section length is lower for class A. And so that means the ROI needs to be 1 meter. So the license plate of each vehicle needs to be captured within a distance of 1 meter. If, for example, a license plate is before or after this 1 meter ROI, then it will not be taken into account. Nevertheless, this will be the next chapter, the performance. We ensure the highest performance in both situations, in class A and class C. For class C, it's 4 meters long, the ROI. Then the lanes per camera, where our homologation or the metrology in Belgium has accepted our solution, is for class A in cities, for example, up to 150 kilometers. 1 camera can overview and monitor 2 lanes, and 1 camera in class C can monitor 3 lanes. That means if you have a highway where you have 4 lanes, you need 2 cameras to monitor all the 4 lanes. Then both, of course, both are highly accurately synced from the time perspective via two independent time sources. So that means one on the NTP time server and on the other on GNNS, here an example of GPS. And last but not least, the new feature is on both. The field of view monitoring feature is as on the Class A and on Class C available. Here a short insight into our user interface. So on the left-hand side, you can see a list of license plate. These are the candidates who might or would probably too fast, drove too fast. And on the right-hand side, you can see for this one infraction, for this one license plate, all the details. So on the top, you see it drove 2 kilometers fast on the section. Then you have on the left-hand side, the point A. So the first camera, which detects in a certain ROI, the camera, the Mazda car, which is red here in the colored photo. You can, of course, also change the photo into a black and white. And below you have all the metadata. That means the ANPR crop out, the country code, the make of the car, the model, the color, the timestamp, etc. And on the right-hand side, of course, the same for the point at the point B. And if you, as user of this interface, detects okay, it's the right vehicle, the same vehicle, then you can simply validate it and go to the next one. So this was to briefly explain you how our solution works, what are the key aspects, and now a short overview of the performance of our solution. So we did a few weeks ago a recent performance report based on our new software firmware. So here is, I would say, the summary out of it. So what we did is we took 4 scenarios, one in city during daylight, one in city during night, and the same for highways. So one during day and one during night. That's why 4 scenarios. In each scenarios, we took 1,500 vehicles. And then I will explain column by column, starting from the left. So you see the column detected. What does it mean? It means that our camera is detecting the object, that means the vehicle, as object. So there's, of course, already a certain performance rate only for the detection itself. Then once it's detected, we read the license plate, and then there is a KPI which we call correct reading. That means, is it well read and what is on the license plate, so versus the reality. And so this performance KPI is in this column, correct reading. Then the next column, and that's why it's the biggest one, I think it's the most interesting and column, it's the multiplication. So you calculate the column detected times the reading column, and you will go to, in the first scenario, to 99.2%. That means in cities, 50 kilometers, 70 kilometers per hour, during day, we achieve in this ROI 99.2% of performance. On the next columns on the right, the country code, you see, if we compare now all 4 scenarios at the same time, that it's also almost always more than 99%. So here in this example, it's always more than 99%, even sometimes close to 100. Then the classification, that means the vehicle classification can be van, passenger car, bus, motorbike, etc. This is also more than 99% in all scenarios. The make and model, which is an example, is the Audi A4, for example. Audi is the make, model is the A4. And in this 4 scenarios, we have during daylight also a very high score, up more than 99%. What you can see in comparison is that during night, it's lower, even if it's still more than 95%, which is excellent. But of course, during night, it's more difficult to detect the different details between several car models. Then there are two columns regarding colors. So there's either it's wrongly recognized. So here about 2.5% errors out of this data set. And some are even there's no detection because it was for our AI not recognizable or not identifiable. So that means you can sum up both columns and you know what is more or less the performance rate based on the color. What you can immediately see is also that during night, we don't do this feature because it's, of course, highly dependent on day, so visible light, on sunlight, and during night, even with external lighting, external illumination, infrared or visible, it's very, very difficult, almost impossible. So to summarize this slide is what you can see is that we definitely work between at least more than 98%. Our target, as you can see, is even more, so even on top, so more than 99%, not only for the detection and reading performance, but also for the country code, the classification, which are, I would say, in the first step, the most important KPIs when it comes to performance. Make and model, also very good, I would say. So for police who wants to search for certain cars at the same time, can be very interesting to know this. Now the functionalities. So our QCAM5 is a camera which can be used for the homologated or for the average speed as a solution, but not only. That means this camera as a hardware product can be used and implemented also for other solutions at the same time. So that means I will go now to all the functionalities which you can combine as you want for your certain application and scenario. So the QCAM5 registered or registers a certain amount of data, of course, license plate. Here I take on the picture the example of the red truck on the Champs-Élysées in Paris. So the country code, then the classification. There's here, of course, the heavy truck. Then the ADR plate. ADR plate is the orange plate in front, what you can see on the red truck below. This indicates if there is a hazardous liquid inside this truck. Then which make. So we have more than 180 makes in our database. And then the models, we have even more than 1,300 models, different models, car models in our database, which we can differentiate. And last but not least, the color. There we can differentiate between 10 colors. Then more or less usual, of course, on which lane it drives this specific car, in which direction. And what is not usual is that we can estimate the speed based on image analysis. But this I will go in a separate slide more in detail. And of course, a highly accurate timestamp, which is very, very important when it comes to average speed, especially. All these data which are created, analyzed, recognized within the camera itself, because in our camera there is an embedded processor from NVIDIA. It's recognized and process everything inside the camera, and these data can be sent afterwards either via cable, Ethernet cable, or via wireless means, 4G, Wi-Fi, etc. That means on a pole, a very simple installation could be one camera on one pole with one electricity supply, and that's it, because the data can be sent also wirelessly. Now, when it comes to ANPR camera, our ANPR camera is based on the NVIDIA TX2 platform, processor platform, which is specially designed by NVIDIA for AI applications. Our sensor is a 5 megapixel black and white sensor for the ANPR part, where you can choose also the different focal length, 16, 25, or 35 millimeters. As I said, all the aspects, all the recognition algorithms are based on AI, and which is embedded on the camera. Then on the ANPR black and white picture, we recognize the license plate, the country code, and all these data can be sent also to your system if you have already a back office solution via an open API. We recognize all these metadata up to 300 kilometers per hour, and as I already mentioned, up to 3 lanes per camera. The next one is the overview camera, so it's the color sensor, also 5 megapixel, based on the same processor, NVIDIA processor. This takes color images and also color video. So that means we are able to stream videos via the via cabling or via wireless, and we are ONVIF compliant and compatible for video streaming. Also very interesting to know. Our camera, so the QCAM5, as I already said, is we are not only making ANPR, but we are identifying at the same time many more vehicle characteristics. Of course, the vehicle classification, we have the standard 10 categories, so car, bus, van, heavy truck, light truck, etc., with trailers. And what is very interesting to know is that this can be extended due to the fact, or thanks to the fact, that we are basing our algorithm on AI. That means if a certain client, a certain situation, a certain city wants to have a specific category, either it can be, for example, a tuk-tuk vehicle class in Asia, we can, based on a data set, train our system also to detect this class. Then the make and model recognition already mentioned, so the Audi A4 and the color recognition with the 10 colors. Only one remark here. As I said, the color recognition is really meant for daylight, where we have high performances. During night, it's difficult. Then our camera is also detecting ADR plates. These are the plates where most of the time trucks are transporting dangerous goods. So these orange plates have the advantage to be similar to the license plate because they reflect also infrared illumination. So that means even during night, we have the same precision, accuracy like for license plates. Then also very, I would say, unique selling point for our camera, ANPR camera, is that it's also there is also the object detection inside embedded included. So that means our camera is not only able to recognize license plates and all the characters I showed you before, but also different type of objects. So that means it increased the versatility of our cameras because it can be used for several different applications at the same time. So you don't need as end client to buy several devices, hardware devices for several applications, but you can merge all your requests, your needs in one hardware device. So here's a slide with some examples on a railway crossing. So you can detect, our camera can detect trains. For example, within our railway solution, which we have, is of course a very important feature. Then also the barriers, the traffic lights, which are blinking, can be red light, what else? Then the object on the level crossing itself. So if there is, it can be a vehicle, but also a box or a backpack, etc. It can be recognized, and for traffic point of view, traffic safety point of view, can be very interesting. Then also cyclists, and last but not least, also the pedestrians. So these are, of course, not vehicles, except the train, but the pedestrian and cyclists is within our AI for the object detection. I already mentioned that we are able to measure the speed based on the image analysis, which is also quite interesting. And of course, we can also propose and offer an alternative to counting loops, because our camera is based, as you understood, on also on object detection and on image analysis, of course, thanks to our AI. And if you calibrate the camera very well, for example, during commissioning, you are able to have a very accurate speed measurement based only on image analysis, so without LiDAR or radar. And it can count vehicles because you can put virtually within the camera some lines where it can replace in certain areas or application the induction loops which are normally inside the ground physically. A feature which is of course well known by I think everyone in this sector at the moment in the last 2-3 years is the seatbelt and mobile phone detection. Yeah, and this feature we have also inside our camera, also AI based and based on the image analysis. Here you can see an example of the car. So the person with a white shirt has neither the seatbelt nor and at the same time he's using the phone. It's a great example. And this is done automatically. So our AI, each frame, each picture which the camera is taking of one vehicle detects if the person inside has put the seatbelt on or use the mobile phone. So as it is meant for high-end solution, you can combine all previous mentioned functionalities on one hardware device, on one hardware platform, the QCAM5. So we also, at the same time, we use very high-end components in this camera to ensure that your needs can be achieved and satisfied thanks to a very high qualitative product. On top of that, we are a company of a certain size, which means we have development teams who are able to react very fast and to develop also or to train our camera for your specific needs. Examples of a high-end solution is definitely the railroad crossing, where we not only detect ANPR, the vehicle class, etc., but also detect at the same time objects, the red signals of the traffic lights, the barriers, etc. And then another example is we can combine our camera, ANPR camera, QCAM5, with external LiDAR devices, for example, for spot speed, for doing interdistance monitoring, etc. From the hardware perspective, our camera is made out of aluminum and ABS. It has a sun visor, as you can see here on the top, to prevent some sun reflection inside. Then it is motorized. That means on the right-hand side, you can see, or you will see in the next slide also, that it can pan and tilt thanks to an embedded motor. Then the design of the housing is in such a way that it's very compact, small, and it suits more or less in all urban, but also on urban areas, but also on highways, etc., without taking too much space. And if needed, we can paint it in different colors. Here's an explosion overview of the cameras. So on the left-hand side, you see the camera itself, where all the main components are integrated. That means the sensors, the NVIDIA processor, the hard disk, the memory, the 4G antennas, etc. Then you have here on the back, on the top, you have first a waterproof chamber where the network and the power connection go through. Below is the part where you have two motors, which ensures the feature of pan and tilt remotely. And then you have to mount the camera, of course, either on the gantry or on the pole. You have a mounting plate which is designed to have a very easy installation, easy possible installation on site. And you have, of course, the waterproof covers and the cover plates. From a dimension, you can say that this camera itself is more or less 19 centimeters wide and 11 centimeters high. And if you take even the arm at the back, it's more or less 28 centimeters high, or 26, sorry, and 28 centimeters in depth. So more or less, if you have your PC in front of you, it's even less wide than your PC, more or less as high as your screen from a laptop, notebook, and to have your a bit certain dimensional feeling. It is motorized, so the tilt, you have the possibility to tilt it up to 54 degrees down, and from in the horizontal, you can pan it in total 30 degrees, 15 on the right and 15 on the left. From an environmental resistant point of view, the camera is IP67. That means it's fully protected against dust and even for short periods of complete immersion in water, up to 1 meter depth. So it's fully compliant for outdoor solutions, of course, on highways for several years. Then it's EK10, so it's protected against the impact of 20 joules, which it's more or less the 5 kilos of a height of 40 centimeters. If it falls down on the camera, it won't break. From the operating temperature, we are at minus 25 degrees up to 70. This is the operating temperature. That means if you install it and you turn it on the camera, then it can be minus 25 degrees outside when you install it and turn it on. But of course, or not but it can be even lower when it's in operation already. So that means if the camera is installed during summer and during winter it goes below 35 degrees, then it's also possible. But to be on the safe side, we are always putting minus 25 degrees. And the humidity is 10 to 95% of relative humidity. And the key features, to summarize from a hardware perspective, there are 2 sensors of each 5 megapixel inside. From a data connectivity point of view, there's Ethernet, so cable, several wireless possibilities, so 4G, 5G required or available, and the Wi-Fi hotspot. Then the GNSS localization aspect, so we can either work on GPS, which is normally the case, or with the others. Then there's the local storage of up to 1 terabyte inside, which is incredibly high. And so you can store many weeks of data on a highway within or on this camera itself. And on the other hand, you can also downgrade, or you can customize the quality of the image and the video, so you can compress it, so you can take more pictures on the same storage. And it's a very lightweight camera, so 3.8 kilos, and the consumption is, in average, the mean consumption is 35 watts. So last but not least, and you can, if you want, already prepare your questions at the end. So if you want to put your questions, don't hesitate to put it in the Q&A box, not in the chat, but better in the Q&A box. So installation instructions. First of all, the boundary conditions. What do we expect, or what do we see as a good, or our targeted installation should ensure a high performance, and that means that for each vehicle we have at least 4 pictures which are winners. That means great, where we can see everything very properly, and where we need to choose one or at least 4 pictures, but more normally we have even more winners. But this is the minimum requirement. Then 1 lane, depending in the continent or the country. Here for this exercise, we take 3.5 meters as lane width. Then the maximum distance in this exercise, we take a license plate or the distance between license plate and to the camera lens is 30 meters. And if the lighting condition requires, we shoot or we turn on also our embedded infrared illumination, which is inside the camera itself. Then we will go through the pole and gantry installation scenarios, and to have a brief overview what impacts has your choice on the focal length. So if you choose a 16mm lens, you can more or less have the field of view of between 8 and 20 meters. If you take the 25, it's between 10 and 30 meters where the vehicle will be detected. And if you have 35mm lens, then it's 15 to up to 30 meters where you can detect and recognize all the vehicle characteristics with our performance I showed you before. Here are some pictures of our simulation, simulator 2, where you can install or where you can parameterize all the aspects. Where is your camera? How many lanes? On which height? Which is the focal length? So here's an example. On the left-hand side, you see 16mm focal length. The camera is installed on a 6.5 meter high. And yeah, 3 lanes, as you can see. And then our simulation tool gives you automatically what is the pan, what is the tilt you need to install the camera, ideally. But of course, as it can be also remotely moved, so in the pan and tilt, you don't need to be very precise. It gives you an indication how to install, but you don't need to waste too much time on site. You can also adjust afterwards thanks to our remote feature, moving feature. And also the green box is the indication of the license plate, where you can see how many pixels it is wide and height with this in this scenario. So here is a simulation if it's installed on a pole, for example, next to the road, and on the same pole if the camera is lower. On the next hand side, these slides, I won't go, of course, into details. It's I'm of course happy to explain you in details afterwards. But what is here is especially interesting for those who wants to install the cameras on site. It shows you three graphs in one table. So more or less, if you have one lane, you can go, and so on the y-axis is the camera height, and on the x-axis is distance from the road, and it's with a reference of the middle of the road. So if you have 2 lanes, 2 times 3.5, that means the middle of the road is 3.5 meters from the road side. So that means if you have here the light green on the right is meant for the one lane scenario. You have 1 lane, so you can go up to 14.5 meters from the middle of the road. You can position your pole and install the camera. If you have 2 lanes, then the middle, so the between dark and light green, you see how when you have chosen a height, how far you can install your pole from the road. And the dark is when you have 3 lanes. There it shows the possibilities of choosing a height, and then depending on the height, you can choose the distance to the road. This is a scenario for the 60mm lens. Also here a table with the same information, only the boundaries where you can see the maximum height, the maximum distance to the road, and then 2 examples. If you choose, for example, with 1 lane, 4.5 meter as height your camera, then you know that your distance to the road, which is also indicated here with the arrow, red arrow B, then you can know, well, you know immediately you can up to 9.25 meters install your pole from the road. The same, an example with 6.5 meters with 2 lanes, the same. And the same slides now for 25mm lens, you see it's different. That's why it's always important to choose the right lens for the right situation. And finally, also the 35mm lens. So this is, we will be, of course, glad with my colleagues to explain you if needed, this in more detail. So, and last but not least, of course, I'm sales, so it's always a it's a nice question. Why to purchase a QCAM5? Of course, I'm convinced that it's the best camera in the world. But let's stay more, I would say, objective. So it's in the first point, it's a European product. So it's entirely designed by Macq, and so in Belgium, and it's manufactured in France. I don't say that all components are from Europe. So of course, as you already heard, NVIDIA, we have also other vendors inside our camera, which is not European, but mainly the main engineering power and yeah, is done in Europe. Then next point is that we use very high-end components inside the camera, which leads to a high performance of our KPIs. Then we design it to simplify the installation and the maintenance due to its lightweight, its motorization of pan and tilt, and the field of view monitor, and due to its design also and its connection possibilities, it can be seamlessly integrated within your city, within your on your highways, etc. And in our back office MQ, Macq Mobility Manager, it can be integrated without any efforts. And a very important aspect, I think, for clients, but also for partners, is to know that we are a Belgian family business, and we are celebrating this year our 100th anniversary, which of course indicates that our company will probably also last for the next 100 years, which and that means, of course, if you buy something at Macq, we will make sure also in the coming years that you can maintain it, that you can replace it, and that you can, and this is probably the most important, that you can count on us if there's a problem. We have many certification, also the ISO certification. We are, when it comes to ANPR market, we are more than 20 years in the business, so a certain experience. And this is a objective point is definitely that the quality proves that the first camera we designed in 2000, the G1, achieved the lifetime up to 15 years in the field, which is quite impressive, I would say. And we have different support services, which are a 24/7 support if required. So I hope that you learned few new aspects of our camera. Also for our homologation, that it's now in Belgium active, and we have it officially, where we are very proud of after 2.5 years. And if you have any question, either you can ask them now directly, or you send us a mail. Either I or my colleagues will answer you as soon as possible. Thank you very much already. So let's see if there are questions. So the first, of course, yeah, it's the approximate price for the camera. This is, of course, an interesting question, of course, always. But as you can imagine, it depends the situation. That means, what do you need really? So because we have the camera itself and all the features you would like. So to say you something, I don't want to say it here because it depends your situation. So I would suggest that you contact myself or on this address to have a more detailed and yeah, tailored view of pricing for these cameras. But thank you very much for this question. Let's wait 1 or 2 minutes. And if there is no other question, which is normally a good sign, that means it was more or less understandable, I hope. So that means we can, yeah, close this meeting. I would say I see to my colleague here, who is the administrator and who organized. So thank you very much to Natalie. So thank you very much. And so I would say we close here, and thank you very much for your attention today. It was a pleasure for me to introduce you in this aspect if it was new for you. And I hope if it was not new for you, that you learned few new aspects from our camera QCAM5 and of our now homologated solution based on our QCAM5. Thank you very much, and see you soon. Bye-bye.